At the end of the topic, you will be able to learn about hierarchy in number system, know the properties of each number system.
Here are the hierarchy of numbers which start from the countable numbers called natural numbers, followed by whole numbers, integers, rational numbers, and irrational numbers. All these numbers together are called as real numbers. Note that you always start counting from 1, 2, 3, and so on. These numbers are called as natural numbers. Natural numbers are used for counting, so they are also called counting numbers.
Properties of natural numbers. Natural numbers are the numbers that we use to count. The set of natural numbers is usually denoted by the symbol n, such that n is equal to the set of 1, 2, 3, 4, 5, 6, so on. Natural numbers are represented as equally spaced points on a number line, increasing endlessly only to the right side of 1. The sum or product of two natural numbers is also a natural number. This is not always true with differences or quotients of natural numbers.
Counting numbers including 0 are called whole numbers. They are denoted by W. Thus, W is the set 0, 1, 2, and so on.
Properties of whole numbers. The set of whole numbers is usually denoted by the symbol W, such that W is equal to the set of 0, 1, 2, 3, 4, 5, 6, and so on. Whole numbers are represented as equally spaced points on a number line, increasing endlessly only to the right side of 0. The sum or product of two whole numbers is also a whole number, but the difference or quotient of two whole numbers is not always a whole number.
Let us see the formation of the set of integers. 0, along with natural numbers, form the set of whole numbers. Whole numbers, along with negative numbers, constitute the set of integers. Thus, the set of integers contain negative numbers, 0, and positive numbers.
Properties of integers. The set of integers is usually represented by the symbol z, such that z is equal to a set of all infinite negative and positive numbers along with 0. The integers are represented as equally spaced points on a number line, increasing endlessly on both the sides. Whole numbers greater than 0 are called positive integers. Their opposites, which are less than 0, are called negative integers. 0 is neither positive nor negative. The sum, difference, or product of two integers is an integer, but the quotient of two integers is not always an integer.
Rational numbers. The number of the form P by Q, where P and Q are integers and Q not equal to 0, is called a rational number. Now, let us study about irrational numbers. We saw that terminating decimals can be expressed in the form of rational numbers. Similarly, non-terminating repeating decimals can also be expressed in the form of rational numbers. What about decimals which are non-terminating and non-repeating? Such numbers cannot be expressed in the form P by Q, where Q not equal to 0, and so they are not rational numbers. Thus, non-terminating, non-repeating decimals are called irrational numbers.
Properties of rational numbers. Rational numbers are those numbers which can be expressed as a ratio between two integers. All decimals which terminate are rational numbers. Decimals which have a repeating pattern after some point are also rational numbers. If a and b are two distinct rational numbers, then a plus b divided by 2 is a rational number between a and b. There are infinitely many rational numbers between any two given rational numbers. The set of all rational numbers are denoted by q. Q is equal to p by q, where p and q belong to z and q is not equal to 0. Rational numbers are found in between integers. Properties of irrational numbers. An irrational number is a number that cannot be written as a ratio. In decimal form, it never ends. It is non-terminating and non-repeating. Irrational numbers are also found in between integers. Real numbers. The set of real numbers is the set of numbers containing all the rational numbers and all the irrational numbers. Real numbers are all the numbers on the number line.
In this topic, you have learned
natural numbers are represented by n is equal to 1, 2, 3 and so on. Whole numbers are represented by w is equal to 0, 1, 2, 3 and so on. Integers are represented by z is equal to -2, -1, 0, 1, 2, 3 and so on. Rational numbers are represented by q and are of the form p by q, where q is not equal to 0. Irrational numbers cannot be written in the ratio form. Real numbers contain both rational and irrational numbers.
at the end of the topic, you will be able to
Define irrational numbers. Prove that a number is irrational.
When the consecutive rational numbers are represented on a number line, gaps are found between them. All the numbers cannot be represented as rational numbers. That is, all the numbers cannot be represented in the form of p by q, where q not equal to 0. Difficulties in expressing the length of the diagonals of certain squares, for example of side equal to 1, in the form of rational numbers led to the discovery of irrational numbers. The irrational numbers seem to fill most of the gaps caused by the rational numbers. Now, let us study about irrational numbers. We saw that terminating decimals can be expressed in the form of rational numbers. Similarly, non-terminating repeating decimals can also be expressed in the form of rational numbers. What about decimals which are non-terminating and non-repeating? Such numbers cannot be expressed in the form p by q, where q not equal to 0, and so they are not rational numbers. Thus, non-terminating, non-repeating decimals are called irrational numbers.
Now let us see about the irrational numbers. Numbers that cannot be written as a ratio of two integers are called irrational numbers. Irrational numbers are numbers that cannot be expressed as a form of p by q, where p and q are integers which are prime to each other and q is not equal to 0. Irrational numbers in decimal form are non-terminating and non-repeating.
Now let us prove that a number is irrational with the aid of the following example. Prove that root of 7 is an irrational number. Click on the solution button to view the solution. Let us view an example on finding the value of an irrational number. If root 7 is equal to 2.64575, find the value of root 343 correct to 2 decimal places. Click on the solution button to view the solution. Value of an irrational number. Pi is a number which is a constant and is used for many calculations. Pi day, March 14, from 3.14 is observed in many schools. Pi is equal to 3.141592653589238 and so on. The improper fraction 355 by 113 is an approximation of pi accurate to 6 decimal places. 22 by 7 is an estimate.
Now let us summarize the classification of decimals and their relation to real numbers. Decimals are broadly classified as terminating and non-terminating decimals, where terminating decimals are rational numbers. The non-terminating decimals are further classified as repeating and non-repeating decimals. Among them, repeating decimals are also called as rational numbers, and non-repeating decimals are called as irrational numbers.
In this topic, you have learned
Non-terminating, non-repeating decimals are called irrational numbers.
at the end of the topic, you will be able to
Define real numbers, represent irrational numbers on the number line, represent numbers in number line using the process of successive magnification, know the properties of square root of real numbers. Real numbers. The collection of numbers we get by putting together the rational and the irrational numbers is called the real numbers. That is, the union of rational and irrational numbers is called real numbers. Thus, every real number is either a rational or an irrational number.
The real number system is made up of many systems: the natural numbers, the whole numbers, the integers, the rational numbers, and irrational numbers. The natural numbers, the whole numbers, and the integers are subsets of the rational numbers. Each number system has infinite numbers in it. So, rational and irrational numbers also have infinite numbers.
Non-terminating and non-recurring decimals are irrational numbers. For example, root 5, root 11. Square root of every positive integer is not always irrational. Example, root 16 is equal to 4, root 100 is equal to 2. These are perfect square numbers. Thus, perfect square numbers are integers. The square root of every positive but not a perfect square number is an irrational number.
Irrational numbers on the number line. Like rational numbers, every irrational number has a corresponding point on a number line. Any point on the number line corresponds either to a rational or an irrational number. Click on the animation button to view the animation. Let us look at the following example on the representation of the irrational numbers on a number line. Represent root 20 on a number line. Click on the solution button to view the solution.
Representation of real numbers on the number line. The process of visualization of representation of numbers on the number line through a magnifying glass is known as process of successive magnification. Let us visualize 2.765 on the number line using successive magnification. We know that 2.768 lies between 2 and 3. Let us look closely at the portion of the number line between 2 and 3. Divide the portion between 2 and 3 into 10 equal parts as shown. Now, 2.765 lies between 2.7 and 2.8. Now, let us look closely at the portion between 2.7 and 2.8. Again, divide the portion between 2.7 and 2.8 into 10 equal parts. Now, 2.765 lies between 2.76 and 2.77. Again, closely look into the numbers between 2.76 and 2.77. Divide the portion between 2.76 and 2.77 into 19 equal parts as shown. We found that 2.765 is the fifth mark in this subdivision. This process is known as the process of successive magnification. Properties of real numbers. For any two real numbers a and b, a is equal to b or a is greater than b or less than b. The sum, difference, product of two real numbers is also a real number. The division of a real number by a non-zero real number is also a real number. The real numbers obey closure, associative, commutative, and distributive law under addition and under multiplication that the rational numbers obey. Every real number has its negative real number. The number 0 is its own negative, and 0 is considered to be neither negative nor positive.
Now we are going to study about squaring a number. To square a number, just multiply it by itself. Generally, the square of a is a into a is equal to a square. Squaring a positive number always produces a positive number. Squaring a negative number gives a positive number. Here is an example. 5 into 5 is equal to 25, and minus 5 into minus 5 is equal to 25. Let us study about the square root of the numbers. A square root of a number is a value that can be multiplied by itself to give the original number. The symbol of square root is as shown. The positive square root of a is denoted as square root of a, called the principal square root of a. If the square root of a whole number is not a whole number, then the root is an irrational number. For example, the square of 4 is 16, and the square root of 16 is 4.
Properties of square root of numbers. If a and b are two non-negative numbers, then root ab is equal to root a root b. Root of a by b is equal to root a by root b. Root a whole square is equal to a. Root a plus root b into root a minus root b is equal to a minus b. Root a plus b into root c plus d is equal to root ac plus root ad plus root bc plus root bd. Example 2. Find any three irrational numbers between root 3 and root 5. Click on the solution button to view the solution.
In this topic, you have learned
Non-terminating and non-recurring decimals are irrational numbers. The process of visualization of representation of numbers on the number line through a magnifying glass is known as the process of successive magnification. Square root of a number is the value that can be multiplied by itself to get the original number.